Continuing what we were talking about, we already know SOHCAHTOA, right? So we have that mentioned on the other page. These are the three, they're called primary trig ratios, sine, cos, and tan, right, for the SOHCAHTOA. The secondary or reciprocal ratios, so they're called secondary. I think some books refer to as secondary, not that many, but I think most of them call them reciprocal ratios. Right? I don't think anyone calls it secondary. I can't remember where I got that from. Might be my mistake, but we'll call them reciprocal. Right? You can let me know if it's in the book, but I think we mostly just call it reciprocal. Is cosecant, secant, and cotangent. So you do want to know that. Cosecant is the reciprocal of sine. Secant is the reciprocal of cos. And cotangent is the reciprocal of tan. We know tan is also sine over cos. So all of these things we need to know. And again, you have to be flexible. Sometimes tan is sine over cos, and sometimes cotangent is 1 over tan, and sometimes cotangent is, if we take the reciprocal of this, cos over sine. And you go, when is it better? It depends. Right? So sometimes this is more useful and sometimes that's more useful. But if we know that tan is sine over cos and we know that cotangent is the reciprocal of tan, then it's this form or that form. It's 1 over tan, or you just flip this. Right? So you flip this and go cos over sine. And I can't tell you which one's better. It depends on the scenario. Right? So you kind of, again, you got to be flexible. So we want this form or that form. Okay? So it's tangent, cotangent is 1 over tan, or cos over sine, depending on the scenario. Okay, so we've got the reciprocals. All right, so we mentioned that before. And then when you do the reciprocal, when you do SOHCAHTOA, I do SOHCAHTOA, for the reciprocals, I'm just going backwards. So it's this way, and that way. So it's H over O, H over A, and A over O. Does that make sense for the reciprocal? So reciprocal, I'm just reading it. I still remember SOHCAHTOA. I think there might be a short form the other way, but there's no way I'm going to memorize that. So it's SOHCAHTOA, but backwards. For cosecant, it's H over O. For secant, it's H over A. And for cotangent, it's A over O. Does that make sense? Right, so I sometimes write SOHCAHTOA, but I put the arrow that way, saying it's the other way. Okay, so we've got that. Back to SOHCAHTOA, and for the reciprocal, we've got those as well. All right, let's go ahead and start to calculate some stuff. So again, we're evaluating. Always, always, always exact unless otherwise specified. So we're always assuming, we might not state it per question, but you have to try to do exact no matter what, right? So whenever you have a special, how do I know? We're looking for special angles. So look for special angles. Anything that combines 30, 45, so 30s, 45, 60s, also 90, 360, right, etc. Does that make sense? 270, 180s. Does that make sense? And then any combination of that, 180 plus the 30, 60, 40. So that's why I put etc. That makes sense? So we're doing any combination of 180 and the 60, 180 plus the 45, those combinations, or 180 and such. Okay, so those are all considered special or combinations of the special, which are still special. Now, you are allowed to convert whatever you want in your head. Some teachers don't like it when you convert everything back to degrees all the time, but you can do things on the side. So if you're looking at this going pi over 3, what is that? I'm going to show you kind of in a diagram. It's pi over 3 is one of the slices, so it's going to be one of the 3 slices on the top. So when I picture that, I go like this. I go, this is pi. It's one of the 3 slices. So now can you picture what it is? It's 60, right? 60, 60, 60. So you go like that and you say, okay, so it's here. So it's in this first quadrant. So I know that this is actually, I'll do this in purple, I know it's cos of 60. How else do you know that? 180 divided by 3. So there's 2 ways to picture that. It's 180 divided by 3. You don't have to show any of this, right? That's just your brain going, oh, I know what that is. It's 60. right? So some people go, I automatically go 180 divided by 3, so it's going to be 60. Or some people go, I'm picturing it like a slice now, so it's 60. So I know it's 60, which is a special angle. We usually ask you on tests, grade 11 and grade 12, to show us your special triangles at least once on the test. Sometimes we have a space and we're like, draw your special triangles here. So usually there's somewhere where we want to see that you've memorized it properly. We're hoping, right? If you memorized it wrong, we just cry with you, right? Because it's pi over 6, which is the smaller one, right? 1/6. This is pi over 3. I'm trying to get used to only do it in radians. And this will be 1, 2, root 3. So usually we ask you to write it, draw it somewhere. Sometimes on a test we say, draw your special triangles here. And we might say in radians, right? So right there, you draw it, and then that way you can refer to it for the rest of the test. I like to draw it. I need to see it. Okay. So then you go cos based on SOHCAHTOA. So again, you're using SOHCAHTOA backwards and forwards, depending on, look, I'm going to do cosecant and cotangent. So it's a backwards and forwards SOHCAHTOA. SOHCAHTOA, right? So knowing that. So for cos, we're going to go A over H. And, oh, where is this one? My angle is pi over 3. So pi over 3. So sitting here, it's going to be adjacent over hypotenuse. So that's 1/2. Okay, and we are also keeping it in fractions. So there's lots of words around this first one. The rest of them, we won't have to put as many words, but I do want things in fraction. And rationalize. You remember that from last year as well? Fraction and rationalize. Never decimal, and we want to rationalize. Right, so sorry, lots of words around this first one. Fraction and rationalize. All right, so I'm not keeping you just on acute angles because we did more than that. So let's go into this next one here, and we went into the cast rule now. So this one I didn't need the cast rule because it's just pi over 3, right? So it's first quadrant, it's from the regular special triangle. Here, I'm going to need the cast rule because, look, it's 11 pi over 6. That is no longer in the first quadrant. This is okay because it's just on this one special triangle. How do I picture this? So again, I'm going to keep drawing it. It doesn't ask you to draw it. So all these diagrams here are kind of for myself, right? But I like to draw it. So I'm going to go 11 pi over 6. The way I always picture it is I go 6 over 6 is 6 over 6 is this, right? Is that okay? 6 over 6 is 1 pi. 6 over 6. And then I have 5 left, 5 of 6 slices. So I know there's 6 slices here. I don't draw all 6 slices. I find it gets kind of busy and I'm like drawing so many slices, I'm wasting my time. So I know that's 6 over 6. Okay, so 6, I'll draw that on the side just so you know, 6 over 6 pi for that half. Then I'm going to continue it now. So I want to continue this line and I want 11 pi over 6. So how do I know where to stop the line? How much is 2 of these? 6 over 6 would get me 12. So I know this is 12, so I'm 1 slice away from being a full circle. Does that make sense? So I know it's 12. I go, wait, if that's 11, this is 6, the full slice would be 12. So then I know it's closer over here. And this little related acute angle, how much is left there? Pi over 6, 1 slice left over. Okay, pi over 6 is my 1 slice left over. Does that make sense? 11, think of it in terms, take away the pi. Sometimes I go 11 over 6. You know that's really close to 12 over 6. So if you're thinking I cut the pizza into 12 slices, I'm 1 slice away. So sometimes taking away the pi makes you less complicated, makes it less complicated. Okay, so it's 11 over 6, so you go, okay, so that's 12, so there you go. Okay, so then that's 1 more slice. So then you're answering it using this triangle now. Except, why did we draw it? Every time we draw it on cast rule, I kept saying, the only reason we drew it on here was to take away a mark. Haha, just kidding. Was to look for negatives. But that's where you're going to lose a mark. So you drew it here, you better look for negatives. So in your brain, you go, what negatives? What negatives can I possibly be losing marks for? That's literally what all that this does is that it's a place to lose marks. We don't want to take away the marks, so please don't make me. Whose quadrant are we in? C. Is this cos? No. So it has to be negative right away there. right away I put the negative. I'm going, oh yeah, you're not going to take that negative mark away from me. I'm putting it right there. That's literally, as soon as you're drawing on cast rule, as soon as you're drawing on quadrants, look to see if you didn't drop a negative. Sometimes there is a negative, sometimes there isn't, but that's really the whole point of the cast rule. Okay, you have to look for negative. So I'm in the C quadrant. This is tan, therefore it's negative. Okay, and then you do the ratio. So I can go to this triangle. Remember, it's drawn somewhere on your test. So pi over 6, it's TOA. So it's sitting here. It's your reference angle. TOA. TOA. So I'm going to go 1 over root 3. And do I leave it like that? Definitely not, because you have to. Do you have to? Yes. You have to rationalize. Will you lose marks each time? Yes, you will. Okay, you cannot still be losing the rationalizing mark. Okay, so this is negative root 3 over 3, and now we're done. Rationalize, finished. Okay, let's do 2 more. Cosecant. So I went into the second, reciprocal ratios, right? The secondary angles. Okay, reciprocal ratios here. So even though it's cosecant, I still draw it the same way. And then I'm just going to do this ratio backwards, right? So don't worry about anything until we get to there. So we're going to go equals. I'm going to do equals, and then we're going to wait for a second. Now, first draw the quadrant. So I always draw the quadrant first. I like to do that. Again, you don't have to. If I don't say draw a diagram, you can just do all this in your head. Some people go, I picture it now. I go 5 pi over 4. I know it's in which quadrant. I know the ratio is related to acute, and you can start to do it in your head. That's fine. Okay? If we ask you for a diagram, it means I want this. So tell me which quadrant. So again, I do 4 over 4 gets me here. Does that make sense? 4 pi over 4. That's my half circle. Then I keep going, so you don't have to write that. Then I keep going. It's 1/4 more. So picture this half here cut into quarters. Quarters, so that means it'll be right here. 1, 2, 3, 4. I'm cutting that half into quarters. Okay, always think about it like in slices. So that means that this little related acute angle here is how much? Pi over 4, 1 slice more. So that was 4 over 4 plus 1 more slice. So then I know I'm going to use this triangle. This is my pi over 4, and I know that this is going to be 1, 1, root 2. Okay. And wait, I drew it in the quadrant. What are we never going to lose a mark for? Positive and negatives, okay? So as soon as you're drawing, then wait, whose quadrant am I in? Whose quadrant am I in? C-A-S, I'm in T quadrant, M-I-T. M-I-T ratio. Tan or cotangent? No, I am not. So right away, I'm negative. Okay, and again, you can put that down right away. At least you got the negative. I got the negative. Okay, and then you do the rest of it. But that's why we have it in the quadrants. If it's positive or negatives, you always search for that first. And now here, it's cosecant. Cosecant is the reciprocal of sine. So we're going backwards. H over O. So here, if I'm sitting here, H is root 2. Root 2, oops, sorry, over 1. Do I leave it like that? No, I want you to finish up by doing this. So don't leave it over a 1 that doesn't need to be there. So I still want you to finish that up, but you don't need to rationalize because it's not denominator. Okay, one last time. And cotangent. Okay, cotangent. I'm going to draw my here. It's 2 over 2, so that gets me here, 2 over 2. And then another half. So cut this second part here into half. Half. I need another half, which actually brings me here. When it's on the quadrant, when it's on one of the quadrant lines, you need to use the point. So this is 0, negative 1. That I'm going to use as x and y. What's r for my unit circle?
-1.
Just 1. Nope. Radius is always positive. Yep, always positive, so we're going to always use a positive 1. And then cotangent is the reciprocal of, I usually do the triangle. Sorry, I do the triangle this way. So I usually picture it here in the first quadrant. So this is y, x, and r. So tan would be y over x, but instead of y over x, it's x over r. So 0 over 1. Right, is that right? Oh no, so 0 over negative 1. It's y over x. So it's y, oh, x over y, sorry. Cotangent, backwards. X over y, and that just equals 0. There you go. Thank you, thank you. We'll do more next lesson.